Yeah, so Jen and I are going to get into a little bit about the sort of a problems and solutions or challenges and solutions sort of presentation about our project that we've been working together on, which is the Point at Hills Farm. It goes by many names now, but it's in Shrewsbury, Mass. So I'll let Jen introduce herself and Cube 3.
Right. So as Kate said, I work at Cube 3. We've been working on this project for quite a while. It's not the first passive house project I was exposed to at Cube 3. That would be Northland. But this will be the first one that we've built. And so it's exciting to have influence in all of these markets and be able to bring this experience there once we get to it. If you want to change the slide. So someone was asking earlier where our offices are. This is where we are right now, except the Lawrence office will soon be in North Andover. So we'll be able to influence across the country.
We are having automatic slide transitions that I was not expecting. So if you don't mind, I'm just going to pause it real quick, Shannon, just in case. And I'm going to just make sure that that's not going to happen throughout the whole thing because that's going to be crazy.
Good thinking, timing, right? Well, it's a beautiful presentation, and we're all excited to learn what you're going to bring to the table here. It really is pretty.
Yeah, it's a nice site. There's a huge hill, which was a problem when we were designing, but it ended up being just two buildings slab on grade with a lot of blasting.
Okay, so where we left off, apologies for that. So at Stephen Winter, we say we make buildings perform better. As Shannon mentioned, I'm on our newly named High Performance Building Solutions team and mostly work on passive house projects, both retrofit and new construction. But we have a range of other services that include sustainability consulting, accessibility consulting, all the different green program certifications, et cetera. So I'm just going to give a little bit of background about this particular project. So like I said, it's in Shrewsbury, Mass. It's 93 units across two 3-story buildings. The project team consists of Cube 3 and Jen's team, BLW Engineering, who's our MEP, Delbrook, the GC, Vetus Engineering for structural, Stephen Winter Associates, we're working as the CPHD. And then we have a separate verifier, Sustainable Comfort Inc. And this project is being certified under FIAS 2021. And similarly, just a high level, a little bit about the makeup of the building. So we have our above grade walls are approximately R28 with 3-inch exterior mineral wool and then mineral wool in the cavity. We have Intis Supera 74 windows is what we landed on, and Jen knows that we've gone back and forth a little bit on the windows.
Up until yesterday.
Up until yesterday. So we landed on an SHGC of about 0.39, and I'll talk a little bit more about those specifics in a bit. High performance glazing, high performance spacer, roof at about R51, pretty typical. Slabs R10 under the slab, air source heat pump for heating and cooling, ERVs for that mechanical ventilation, and then this project does have a gas boiler for GHW.
It is, however, prepared to move to fully electric when they eventually replace the gas equipment.
Yeah.
And I think this is Wynn's last project that has any gas equipment in it at all.
Woohoo! That's what we like to hear. Yeah, so as part of the FIAS 2021 electrification readiness, as some of you may be aware of, is part of that. So quickly, I just wanted to highlight here. So FIAS and PHI, those are our two pathways that we can go for passive house. This project is going our FIAS route. So they brought us on as the CPHC, the Certified Passive House Consultant. And then we have that verifier who CSI, Sustainable Comfort Inc. is acting at. And then FIAS is the main reviewer for all of their certified projects. And then we don't have to go through all this, but in case the slides are available later, I just wanted to offer this. These are some of the co-requisite programs that go along with the FIAS Plus. This slide is a little bit outdated. It does say FIAS Plus 2015. The current version is FIAS 2021, but all of the co-requisite programs remain the same. Versions might just be different from what they were with the 2015 certification. And then as Jen mentioned, this project, even though it has gas, is electrification ready. And some other aspects of that are the EV ready parking spaces, some spaces being EV capable, and then conduit, et cetera, prepared in some of those spaces, like with the gas boiler. And I know this is probably a very technical crowd, but Passive House in general, if you've not worked with it or aren't as familiar, it's performance-based, it's extremely stringent, and it is a comfort-based standard first. That's how we like to talk about it. We want the occupants to be comfortable. In the breakout room, one of the gentlemen that was speaking with us mentioned that one of his Passive House projects that he worked on was the most comfortable building his tenants had ever been in. So just goes to show how comfortable these projects can be. And then just the main things that we look at when we're looking at multifamily specifically, we want to make sure that the DHW is efficient, high performance windows and doors and envelope, obviously, that continuous insulation, thermal bridge free construction, and just efficient systems overall. And the domestic hot water and the efficiency, lights and appliances, those are the ones that we focus in on more specifically, even though they're not necessarily part of the criteria that you have to meet in order to pass House. So today, Jen's going to kick it off with the first two, but we have our 4 challenges, 4 solutions. We're going to go into these. I'll let them speak for themselves, so I don't want to spoil it for us as we get through here, but I'll switch the slide and Jen, you can take it away.
All right. So again, just a little information about Cube 3's efforts moving forward with the green initiatives that we have. Like we said, this is our first Passive House project, but we are building on the knowledge that we gained or have gained working with Northland. And we have people who are certified in all of these programs to help us increase the sustainability aspect of all of our projects. So we've been building off of the information that we have gathered from other past projects, and we're also kind of acting as the springboard for other Q3 projects, particularly the ones that we have with Win that are going to be pushing for Passive House certification through the various programs. My details have shown up in other projects already. That's kind of exciting. And it's been very exciting to work with Win as they've been instrumental in pushing us forward here.
And I apologize, I don't think I had Win on our team slide, but Win Companies is
It's
the major player and the reason that we are doing this project.
Yes.
So big thank you to them.
So one of the biggest issues that we've run into is fitting all of the mechanical into the ceiling. We started with a typical 10.8 floor-to-floor height. We were hoping for an 8.6 corridor. That didn't happen. Right now, we've managed to get it down to 8 foot in most of the places. There's going to be a few select areas that are probably going to be a little lower. But we did this by adjusting just about everything. We've changed the floor structure in the corridor from 2x10s to 2x8s. We've massaged duct proportions. We've asked structural to help us figure out pocketed headers to try and make as much space as we can getting into the units with all of these extra ducts that we need to fit. The next slide shows where we started. So between the 2 top plates and the bottom of the truss, we had less than 6 inches, and that wasn't going to fit anything. So this is, as I said, where we started. So everything's this normal, typical size. And then we reduced the joists, we pocketed the headers, and we also have been looking at new materials. For instance, we hadn't heard of this duct insulation before, and it seems to be pretty interesting. Like it's bubble wrap almost, and it's going around, and it gave us just that little bit of extra space that we needed. And also, in order to give, again, as much space as possible, we did switch down from our 8 everywhere to our 6 where we could, just to squeeze as much space out as we can. Soffits weren't really where we wanted to be in the units. The client preferred that we didn't go that route, but we do have some bathrooms that we've dropped the ceiling down to 8 feet just to get everything where it needs to be. And this one came up really early in the process. When we first started the project, we didn't know that it was going to be passive house. So when we placed the buildings, they were tight to the property lines, particularly in the places that you can see circled. And we had to maintain the separation between them. And then when we found out we were going to be passive house, we had to add insulation on the outside, and that bumped our wall thicknesses up to the point where we were over the property line. So we had to coordinate with our civil engineering team to shift everything around a little bit so that we could fit on the site properly. That kind of, it helped create the slight twist in building 2, which is the one on the lower one. And it just kind of highlights the need to make sure that everyone is on the same page to start, and everyone's communicating and talking as much as possible throughout the process so that everyone gets everything done.
Yeah, that's a great point, Jen. With integrated design, we ask that if you're going to bring on your passive house consultant, bring them on as early as you can. Sometimes we can, help flush things out like this early on, or we can bear warnings, but having everybody, the civil engineer, the structural, everyone involved as early as you can, with the understanding that contractors are not always bid out right away, but it allows for a good collaborative experience and an easier design process for sure.
And I'm not sure if our civil engineer was on the slide either, but that's Beals and Thomas, if it wasn't.
Thank you. So I'm going to talk a little bit generally about multi-building developments. So it's, this is not the first project that we've seen. Jen, you mentioned Northland, which is several building projects, some of which going passive house, some of which going other levels. But this was the first one that I worked very intimately on. That was 2 projects, both going passive house, both in the same development, and both being phased at the same time, constructed at the same time. So some challenges with that. Or I guess we'll start with some good things with that. It's all being done together. You don't have to worry about bringing subs on site twice. You can work on both in kind of tandem or following one another. But some challenges are, you find out something doesn't work on one building, you really quick have to figure out that solution before the second building gets its foundation poured, or whatever the case is. And a couple individual things that happened with this project. Orientation, as Jen mentioned, was one of the things that we had to consider for shading solar exposure. And even though the buildings look very similarly oriented, they both have a lot of east and west glazing, which for passive house, some of you may have come across this before. It can kind of make your model compete with itself a little bit because you have that solar exposure on the east and west sides. But one of the biggest things I believe for this particular project was the 2 buildings being different sizes. So obviously some goals, we want to make sure that we're keeping components and specs consistent. You don't want to have one R value in the wall on building 1 and then a different R value on building 2. Things like the windows and the solar heating coefficient, which can help with your heating or cooling demand. Both of those things, you want to keep those consistent across the building for visual, for architectural appeal, all of that. So those were some of the things that we came across for this building. Building 1 was cooling dominated, and building 2 ended up being heating dominated, which in the early stages, it's kind of come out in the wash as the project has progressed and we've nailed down some of the final components. But early on, when I was still holding some placeholders and we hadn't flushed out all of the thermal bridge modeling and exploring our options for windows, we had a couple different manufacturers that were, on board or looking to give quotes for the project. And it all became very important to make sure that we could keep the same component for both buildings. We ended up with that SHGC of about 0.39. 0.41 was in the mix for a little while, but we tend to not like to go that high. We don't want to risk overheating in the building that was, heating dominated or cooling dominated. So it was a lot of plug and play, but that's another perfect example of why we want to get our consultants on early and get everyone in the conversation and get the model plugged in and see where we can plug and play some of those components. So then another challenge and solution, splitting scope and staying organized. So, I don't want to beat a dead horse, but getting everyone involved early is great. We want to make sure that everyone's involved and the scopes are clearly outlined for this project. At least for myself, it was a little bit unique in that Stephen Winter Associates was not acting as the verifier, which on other projects that I've worked on in the past, a different group within SWA, but still within SWA was acting as our verifier and doing all of the on-site inspections. Excuse me. Which in that case, something like, oh, I didn't see that picture come through. I can dig through our drives because I have access to those folders and just pull that information. Or I can go look for an inspection report. So in this case, it's been ultra important to make sure that the verifier SCI, and they've been fantastic in communicating and getting inspections on the schedule, but making sure that I get to see their on-site inspection reports because I'm not actually out in the fields looking at things in real time. So they're also going to be doing that co-requisite program testing and documentation. They're doing the time to hot test for the DHW, whereas I was the one that had modeled it in our energy model. And then, they're verifying that the air tightness details are coming to life. And I was the one that had done the original air barrier review. So it's been a lot of back and forth and a lot of sharing of resources and a lot of sharing of information. And it can definitely be done. And we were both brought onto the project early and we were able to communicate. And so far it's been great. And so far so good. So we'll continue that open line of communication as construction continues, but we are in the thick of it now. And then ultimately I will be doing our final submission to FIAS for certification. So I know it was in the chat, but we did leave our emails here if anyone wants to take note of those, or if your question today does not get answered, please feel free to reach out. We're always happy to field questions after the presentation, but that's all we have.
Fantastic job. Thank you so much, Kate and Jennifer. That was really great. A lot of good takeaways. I was taking notes myself and throwing them in the chat for sharing. So Sean, what do you think? Any big takeaways for you? My favorite was really stay consistent with the materials across the buildings, even though they're of different sizes. Make it simpler for the contractors to get there and order in price, right?
Yeah, no, my takeaways again is just that communication and the fact that from a pre-construction standpoint of the integrated design process of bringing on the right players and again it's still this like transition of all projects. Doesn't matter if you're passive house, which you all should be passive house, or aiming with passive house principles, to just be able to plan better by having that team on board. And I know from a construction standpoint, builders have to have a bit of a different business model of potentially being hired as a consultant to be involved in these early conversations, to just offer expertise and be able to assist before you're hired on as a builder. And so I think as we're making our buildings better and looking at the retrofit side of things, there's a real opportunity for the construction industry's business models to change and adapt when we're looking at this whole again comfort standard. And again, I love just where the teams are at with where they're at this project, and it's going to be an exciting build. So great stuff, great input. Turn the tables from presentation to question period, and we do have a good list here from Tom, Prescott, George, Leanne, and Taylor Wark. We'll start with those. If you have any more questions, please put them in the chat, and we will collect them and dive into things. So, Tom, you get to go first.
Good morning. Nice little beard you're growing there. I love the look of the building. I'll be curious to see how the occupants like it and so on. I notice you have some nice big shade trees there, but not much overhang or shading on the windows. And so I'm wondering how you address overheating risks, especially for future climate, in terms of not only shading the windows, but having trees that will be adapted to the future climate as well. Thanks.
Well,
Yes.
there are a bunch of trees on site already, which is why those are there. But I think that the windows we chose helped to cut down on the need for shading?
Yeah, so the solar heat gain coefficient that we did go with, being that it was relatively high, as I mentioned, we wanted to make sure that the overheating risk wouldn't outweigh the benefit of having more heat gain on the project or the building that needed it. So some of the on-site shading, as Jen mentioned, the trees that are already existing are taking care of some of that. But then also, and that's a great point, because one of the solutions on projects, not this project, but some other ones where they have this multi-building development, is things like shading devices. This project did not need to go that direction. And I think, if I'm not mistaken, building 1 was cooling dominated. So that was our larger of the buildings.
Yeah,
But
that's
the
where
way
our
it was,
amenity is too.
right. And so the way it was being shaded by the other building kind of offset a little bit of that. So yeah, so definitely something that's on our radar. The future climate, it's tough right now. Unfortunately, I don't think we can pull in future climate data into the energy model for like certification purposes. It's probably available, but it's not what's used to certify. But yeah, I think overall, just the shading and the site layout for this particular project, I don't want to say it was lucky, it was a lucky draw, but it kind of worked itself out in that way.
Tom, does that work for you?
Well, I think I think most of these climate zones are gonna have significant increases in cooling loads, within the next decade or two. So you might want to think about putting in some brackets or something else so you can add shading later as you need it.
That's a great point. Yeah, it's not something that I've seen. Like, we talk about electrification readiness, but what about shading and overheating readiness? It's a great point.
Thanks.
Yeah, I know that's a great point there, Kate and Jen. I mean, when we talk about buildings, again, the whole word of resiliency is really kind of taken over in my mind and kind of moved away from sustainability. And so anytime you talk about buildings, it's like, how are they resilient to just other factors that you may not encounter in the designing for today? And I know someone put a question about, gas and electrification and being electrification ready, which is really insightful to kind of plan for future proofing of the buildings. So great insight. And so just another little tidbit is, hopefully the builder is on board with everything you've done, because in BC we did have a builder who hit a tree, and that was part of the shading device, and then thought to deal with some cost cutting and change the windows. And so that building had to deal with some future proofing earlier on than expected. So hopefully the team is on board. And from what you've talked about with the IDP, I think you're there. So good stuff. Moving along, Prescott, you had a simple question, but I know you always have more to offer, so your turn to hop on.
Yeah, well, I wonder if I missed it in the beginning, but I was wondering about the climate zone, but specifically because you talked about one building being cooling dominated, one being heat dominated. I'm like, where does that happen? Although I've heard that that happens on different, like a skyscraper, it'll happen on different sides depending on time of day. They wake up in the heat and they go to sleep in the cool or whatever.
Mhm.
So, simple question about geography, I suppose.
Yeah, and I think a lot of what was happening here was less about the actual location, because obviously they are very close to one another, but more about the density of the building and the actual building size itself. So smaller buildings we do find to be more challenging. Low-rise buildings just in general, especially in the upper climate zones. So more projects that we're seeing in Massachusetts, the low-rise, like 3 stories, 4 stories, they can be tough, and it's tough to balance that solar heat gain with getting the model to pass and being within the threshold. So I think it was more so building size on this one than it was geography.
But
Between
it's
the buildings.
5A, just for the record. Is that where you are?
I believe so.
Yeah,
Okay.
I think so. Kind of central Massachusetts, due west from Boston.
Hey, this is really curious to me. Do you find that there's a form factor that kind of is the fulcrum for multifamily, where it goes from heating dominated to cooling dominated in Massachusetts? I know it's, you might not have enough of
Yeah, no,
a
it's a great
set of
question.
buildings to draw from. But
Yeah. In Massachusetts specifically, it's tough because I feel like a lot of the projects we do work on are lower rise, at least so far. But in somewhere like New York, we do see things over 6 stories start to kind of turn that switch. And a lot of that, it depends too, is it an affordable housing project? Is it market rate? What is the expected density of the building? So within our firm, there's been a lot of research that's kind of ramping up. People on our team are working on kind of looking at humidity in units and whether or not that's being offset by the heat recovery, the ERV systems, and are the units being too damp, and what is the cause of that? Is it just density? But yeah, around 6 stories, I think, is typically where we see it go from heating dominated to cooling dominated, and a lot of it is density in the building.
Thank you. Perfect. All right, who is up next? It's George Ostrow. George, would you like to unmute and ask your question?
Yeah, hey. So if you don't mind, I'm going to preach to hopefully a friendly choir here before I ask my question, because the issue of resilience came up. And in my opinion, dollars and effort spent on fortifying a building for upcoming climate change are misdirected dollars. They really need to be allocated towards reducing fossil fuel burning. So that's just, hopefully everyone is on board with that idea. But yeah, my question is, it's 2-building project. Does it have 2 FIAS numbers? Are they sort of run separately? If one fails and one passes, can you certify one of them? How does that all work?
No, that's a great question. Yeah, we've talked on other projects about this multi-development system. Long story short, yes, they have 2 project numbers and 2 energy models, and they're being run separately. So that's really the meat and potatoes, and how we were able to see how the solar heat gain coefficient being ramped up a couple points can really swing one building one way and one the other way. And like I said, as we've kind of flushed out most of the components in the modeling, they've kind of leveled out a little bit, and they're working a little bit, they're playing a little bit nicer together now. But yes, they are being certified separately. If one were to, knock on wood, not pass, the other one could still get certified, but the goal here is to get both. So
Yeah, of course. Yeah. Okay.
Like a little sibling rivalry going on between these buildings.
Thanks.
No, absolutely. And I mean, I just love how, when you get to design to the same, how, even though it's climate zone 5A, you kind of have this little microclimate between the 2 buildings and how they work with it. And, a lot of times you have to model exterior factors of, trees or mountains or other things, but dive into a model where you've got these 2 buildings and how, you might make one taller or smaller to deal with the other ones. And I just, again, it's insightful when you get the data in the model and you get to play around with stuff. So this is just a great conversation with all these details. So next question is over to Leanne. Leanne, you're next.
And
And
Leanne,
Leanne,
if you can't unmute, we can ask your question for you, but we'll give you another moment here. And Leanne, it might have been answered in the chat as well. Leanne asked, can you talk a little bit about the costs of the projects and how it compares to non-passive house construction?
Well, I can definitely talk to this. This project has gone for a lot of different funding options through the state and federal, and so we were really tight on budget. There's nothing extraneous on this project at all. So we were very careful about what we added to the project. We had a strict, I think, $32.2 million budget that we have to meet. So that's been a challenge for sure, trying to get everything, all the materials in that we need, and all of everything just to get the project working right. Is that, do you
Yeah,
need
that's
more
a good
than that?
answer.
Okay.
Did you guys do a feasibility study and pricing and any comparison at that between the 2, or really once the project gets going and you get pricing, you just keep moving forward?
We kind of just kept moving forward.
Yes, supply chain has a way of influencing that. And lead times. Yes. Yeah, I actually have to get the materials to build the buildings. Sean, you know a little bit about that.
Yes. Absolutely, but I mean, this is what's great about what's happening in that state where you've got a lot of support for design, and when you're looking for funding, there's a lot available. So it's great that again, you talk about the zones of North America that are in heavy passive house development, and this project seems to be in the right heart at the moment, where there's a lot of pulse and a lot of expertise and a lot of people working to do these kinds of things. So this is another great project for the neighborhood, for sure.
Absolutely. Kate and Jennifer, did anybody on the team doing pre-con services express concerns about supply chain issues or labor or training? I know you guys, I don't know if you did the kickoff trades training meeting or if you are planning for that next, since you've got your pre-certification. How are you approaching that, since you guys have sustainable comfort as the rater on this one?
So great question, because this has come up just recently on this project. Mineral wool is being used a lot more in the region. And somebody from my firm actually was just on a chat with them, and lead times are getting pretty long. So for this particular project, the question came up under the roofing deck: can we switch from a mineral wool to a fiberglass bat? And short answer was, as long as it maintains the R value and acts the same way, then absolutely. But that question was driven by lead times and sourcing of things. I don't think we've had our construction trades kickoff yet.
No, I don't think so.
Kelly from the Sustainable Comfort Inc., who's going to be doing our verifier pathway there, she's going to be leading that talk with the trades, but I don't think we've gotten that far yet.
Oh, that'll be a next wonderful milestone. Fantastic. Good luck with that. Who's next?
Well, and Shannon, that's where it's fun, where we can get these speakers back, because this is a lot of pre-con talk today, but when we talk about construction tech, this is the next phase of a great opportunity. So hopefully we'll have these speakers back in soon enough to talk about the highlights of that phase of the project.
Hopefully I don't have too many more gray hairs.
Fair enough.
Yeah, I'm looking forward to phase 2 already. Presentation 2, part 2.
So John, sorry, Alex has a couple questions. So Alex, maybe start with your hot pressing one, and then we'll put you back in the queue. Or is it Alec?
I think it's Alec. Alec,
Yeah.
Can you unmute, ask your question, or would you like us to ask it for you? Not seeing Alec unmuting.
Mike isn't working. Please ask for me. So.
Okay, great. So Alec had a bunch. I'm going to grab his first one first. He wanted to have you both talk a little bit about your approach with ERVs and mechanical room locations. So strategies for where to put it, I imagine, and how to distribute.
Jen, I can let you go first. Was there any leading or driving considerations for the location of the rooms?
Not that I remember. We needed them to be on the first floor and easily accessible to the outside. One thing actually that we did discover is that we were going to need to add some wider doors, because the equipment was going to, when it eventually does go, it's going to need more space to get out, and we don't want to have to like bust a hole in the wall. So that was also part of the discussion that we had a little bit later, was how do we replace this eventually when we need to?
Right.
And then all the distributions in the ceiling, right?
Yeah, everything's in the ceiling.
In the double line corridors.
Yeah.
Right. But central ERV, to answer kind of the second part of Alex's question there, centralized ventilation.
Thank you. Okay, our next question up is from Ramzi Kaur. Ramzi, am I saying your name right? And would you like to unmute and ask your question?
Yes, I guess the question was answered. I was asking what's the HVAC system that was used? Was it existing, new? Somebody said something about gas. What was the configuration of the heating and cooling system? Thank you.
Well, the gas boilers are just for the water, and that was a cost decision. The equipment right now wasn't in our budget again, so it exists, but it just was not a feasible option right now. So we went with the gas boilers with the full intention that when they need to be replaced, they'll be replaced with something electric. and assuming that the technology is progressed to the point where it's not cost prohibitive.
Right. And then for the heating and cooling system, mechanical ventilation is separate with those ERVs. And then we have rooftop condenser units for the heat pumps for heating and cooling. And there's not, I don't think it's one per unit, but there's quite a bunch of condensers on the roof.
Great, thank you so much. Our next question is from Parayak Lally. Am I saying your name right? And would you like to unmute and ask your question?
You're pretty close. It's Porrick, and that's
Porrick, thank you.
that's
We
better.
have met before. Hello.
We have met, yeah. Usually, if it's spell check, it goes to pariah. So you did better. Anyway, sorry. My question was around solar cladding. It's general. Sorry, it's not specific to this project. If it was if it's a consideration. Now I understand what you said. It's a very budget conscious project, so that's probably means no. But obviously, there's a different consideration with these kinds of technologies because of the incentives and downstream benefits. Is that starting to become part of the conversation on projects, or is it still a ways off?
I haven't seen anything for Cube 3.
Yeah, and for us, solar in general tends to be pretty project specific. You hit the nail on the head with this one. It was very budget conscious. So it was more, are we going to need solar in order to pass our source energy threshold for FIAS? And ultimately we were able to pass without. We're starting to see it a little bit more, not so much the solar cladding options. We've seen either, rooftop or parking lot type systems on some of our projects, but we've done a couple lunch and learns in-house where we've heard about the solar cladding options, and it sounds like they're pretty cool. It sounds like they're a new technology, and I do think a lot of projects are going to start considering things like that.
Yeah.
So yeah.
Yeah. Okay. Fair enough. Thank you very much.
Yeah. Thank you.
Great. We actually had a question that we skipped.
By the way, on Rockwool, I used to work there years ago. Their lead times are insane right now. It's like 200 days. So if you can figure out a way to pre-buy the stuff or something, do it, because otherwise it'll be crazy. Anyway, sorry, that's just a comment.
That's a good comment, Parek. Thank you. Thank you for your question and for the advice to everyone out there hoping to source some Rockwool. We did skip a question from Chris Brown, so apologies to you, Chris. Chris was just curious on an educational note. What else would domestic hot water be? Why would anything be otherwise? Can you educate me? So this is when you had a slide that had DHW and I wrote domestic hot water. It's kind of explaining the acronym. But
yeah, I was just I sort of got stuck in the semantics. I was like, how would hot water be anything other than domestic? And I sort of, like I said, I just sort of got stuck in the semantics of it. I was like,
It's an interesting question. I've never really thought about where that comes from. I always just thought of it as, it's always called that, even if it's
commercial,
city water or commercial, or if it's geothermal, like it's just the domestic hot water of it. It's being used domestically, locally to the project. So I think that's kind of where the name comes from. But yeah, the name doesn't change. I don't think it would if it was like, water doesn't come. I guess it always kind of comes from somewhere else. I don't know. I've never.
We've all inherited this acronym from mechanical engineers. And the only other answer I can think of is mechanical hot water. Like, what if you're making hot water for mechanicals and it doesn't have to be domestic? But good question, Chris. You stumped the passive house experts with that one.
Domestic is potable.
Potable. Oh, there you go, Keith.
That's what I would think,
it's not
right?
used for hydronic heating or steam. It's potable.
It's potable. Even if you're not using it for the sink. Yeah. Okay. Perfect.
Yeah, it gets tricky too when you have on-demand hot water generation versus storage, and so you can get these weird acronyms popping up when you're, all that stuff. So anyhow, fun conversations that I'm sure our good friend Gary Klein would chime in and probably give us a history lesson in. So,
and a good joke. Yes.
Yeah.
Well, I'm going to return to Alec. If Alec, you want to come on and ask your third question, or I guess you have two more. And while Alec is getting ready to ask his questions, please drop any more you have into the chat so we can keep this conversation going. We've got a little bit more time. And it looks like more questions are coming in as we speak.
Yeah.
Alex, are you still with us?
Alex is having a problem with his mic. Do you want I think you have a better pulse on the questions than I do, so.
Sure. Alex said, what would your ideal floor-to-floor benchmark be, knowing what you know now? Jennifer, I think that one's for you.
Yeah, I think, well, definitely a little bit higher would be nice. I don't know if we have a set height that would be like perfect. I think it would be depending on what we have running in that corridor. But if we're sticking, especially in-house with a 10-8, I think we'd probably consider in more cases switching out from a 2x10 UL listed assembly to the 2x8 calculated method that we used to make sure we still had that rating in that ceiling. But I don't know off the top of my head what the best height would be.
It depends, right?
Yeah, it depends.
Yeah, and really, I
Okay.
mean, we're in the same process too when like looking at floor systems. I mean, here on the West Coast, we typically use I-joists, and I'm really looking at floor trusses to help with things. And so now it's a combination of, you're looking at these taller buildings of, do you do mass timber from the window to like usually the kitchen, so you get a thinner slab, and then from kitchen to the corridor going with a floor truss to then get all the ducting running through there and having more opportunity. But depending on the height, then you get into sprinkler issues. So it's a total, it depends on location, and then of course duct size. So
Yeah, hey, I think my question was just the foundation and footing strategy. So is it slab on grade or is it crawl space? Was there any discussion of one versus the other? And then, the old passive house question, is there insulation under the footings or not?
Yeah, so I'm not sure if there was consideration earlier in the process than I was involved, but it is slab on grade. And just on the exterior of the footings, typical code levels of vertical insulation, it's about I think it's R10 for, 3 feet, Jen?
Something like that.
But I don't believe there was insulation wrapped completely under the footings. It just down
Nope.
to the footings.
Yeah, we have a little bit
And not even under
vertical.
the slab?
It is under the slab, and we have a little bit vertical on the interior side of the foundation wall. And I can speak to the discussion of what was going on below grade. The original plan was to have a basement under building 2 because of the huge grade change, but that got VE'd out pretty early. And then it turns out there's a lot of ledge under the site, so it didn't make any sense to keep trying to blast deeper. So we stuck with slab on grade for cost reasons mainly.
And does handicapped accessibility factor into that at all?
The entries of both buildings are accessible.
Yeah, but in other
So-
words, does that force the building? Does that eliminate crawl space because crawl space is typically higher than grade?
It would be a longer ramp to get in,
Yeah, okay.
but it would be possible. We just weren't
All the way to
thinking.
Connecticut? Yeah, okay.
Yeah. Just about.
In the snow,
Yeah.
yeah, George,
Fantastic.
it's a good question just because again, a lot of times, in passive house projects that are on slab, you think of doing a raft slab and the thicker edges around, your walls to manage the thermal bridging issues and just how to potentially build that slab easier. And of course it it depends on preference of building typology and frost depths and a whole bunch of different things. And so yeah, those slab questions are always great to just see how different projects do it when in construction sometimes we have too many choices and too many methods, and sometimes it's not right or wrong, it's what the team decided upon. So great question, because that's, again, foundations matter.
Yes.
Foundations matter, size matters, but keeping materials consistent matters just as much. I love it.
Exactly.
Well, Kate and Jen, did you have any other parting comments you wanted to share as we head into the end of the presentation? We've made our last call for questions, and it looks like we can end a little bit early today, but we've had a fantastic chat. So more questions than sometimes we get with longer presentations. So really appreciate your time today. Appreciate you sharing your expertise and looking forward to having you back. Any final comments you want to share?
If you come up with anything, just reach out and ask us questions.
Yeah, feel free to use our emails. We're happy to help where we can.
And you're getting a round of applause in the chat here. We've put your LinkedIns into the chat, so please do connect. And then if you are able, please join us for Reimagine Buildings 24, March 7th and 8th. Consider it a party with continuing ed credits. What could be better than that? Any final comments, Sean? You want to take us
Well,
out?
just as I said earlier, again, Passivos is the comfort standard. So reimagining buildings will be a comfort party. And so get your sleep and your pajamas, because it's going to be a long night of fun.
Comfort with a PH. Well, thanks everyone for joining us. Have a fantastic rest of your week. And we will see this recording online in 1 week. And we will see you at our next events. Enjoy the podcast in the meantime.
Thank you so much.
Thanks, everyone.
Bye-bye.